Alright, so guys, just to remind you, alright, everything we did yesterday was basic trig ratio stuff. Okay, so still make sure you have these on in your head pretty much every time you see right triangle, you're finding something in it, a side length or an angle measure, you need to like think these first, especially if you have angle measures. Alright, Pythagorean theorem can still be used in these triangles as long as you have two sides. There's 30, 60, 90s, and 45, 45, 90s. You can still use them, but if you forget the special right triangle stuff, this will solve all of those triangles as long as you have like an angle. Okay, so out of the stuff so far, I mean, really, this is the most important thing. Okay, it can be used in so many situations. All right, so don't forget those. Okay, we're just adding on to this today. You're still practicing using sine, cosine, theorem. All right. When you do the problems today, guys, you still need to go through those 4 steps. You still need to find the angle, label the sides, pick the appropriate trig ratio, and then solve the proportion. Okay, these steps aren't changing. Even for the finding the angle measures, these things don't change. Okay? And also with the angle measures, just kind of keep in mind, right, these things, the sine -1, cosine -1, tangent -1, those are the things you're using for angle measures. Right? Regular sine, cosine, tangent, which you use for the side length. Okay, so all that stuff is from yesterday. Okay? The first new thing will be just this term. Alright? If I say ever, here's the right triangle, I want you to solve it. I'm telling you, with the words of saying solve the right triangle, I'm telling you, find everything in it. That means all of the side lengths, all of the angle measures. Okay? And really with that, it would mean the 2 acute angles, because you would automatically know if I said solve this right triangle, one angle has to be a right angle. Okay, so I would assume that's not have to be brought up. Right? And this, so if this term solving a right triangle is essentially saying do everything that we've already talked about involving trig ratios. You might have to do the -1 things. Find the acute angle, might not. You might have to do a trig ratio to find the side length, you might not. You've got 2 of the sides, you can still do Pythagorean theorem. Okay, this stuff right here is basically saying use everything that you know about the right triangle so far in order to find what's missing. Right, so there's 2 types of problems you'll see here, or 2 types of setups. I'm either going to have a right triangle where I'm giving you 2 side lengths and say find everything, or you're going to have a right triangle that has 1 side length, 1 angle measure, and I'll say find everything. Okay? Each one of those you'll have to do some kind of trig thing first. All right. The first case where I have, can I go past this, guys? The first case would be one like this that I was saying, where you've got 2 side lengths given, and I said, look, here's a right triangle, and I want you to solve it. I said solve the right triangle. Okay, so this would be one case, all right? And basically what I was saying is, I don't care how you get the sides and angles, all right, as long as they come out to the right answer. If I gave you this kind of problem, I would assume most people would do Pythagorean theorem to find that side. Because when I say solve it, I need to know that side, I need to know that angle, and I need to know that angle. Okay? I'm going to take this away. You can just use E and U tools. Alright? So what I would say is I would assume most people would just set up Pythagorean theorem to find this side right here first. Okay? Probably going to be the most straightforward thing to do. So if I set up Pythagorean theorem here, how would it look? Like what things are squared, what gets added, so on. Okay? And then you would just go about solving out, right? So x squared is 28 squared minus 19 squared. What's 28 squared minus 19 squared? Calculator out. What is it? 423. And then the square root of that is what? What? 20.5. Is it rounded to 5?
Okay, no, it's 20.6.
20.6?
But
Okay.
there's a very long
20.5. All right, put that in. Okay, so that would be my side length. All right. Since, again, I have the term up there, solve the right triangle. That means the other part you have to do is find two missing angles. Okay? Now, so this would be where you would have to go back and set up some kind of trig ratio. All right, and it would all depend on which angle you want to work with. Because just like solving the sides, you're still going through the same steps. You pick an angle, you label the sides, opposite, adjacent, hypotenuse, all right, and then you go from there. So, out of the two missing angles, either angle U or angle E, which one would you like to find? E. All right, so we'll do E. Okay, so the first letter I heard. Is it emo? It does say triangle. Large curve. Yeah. It's going to be like 30. So I've heard. All right, so what I would do once I got that angle, right, pick, then I would label my sides, right? This side right here would be the adjacent one, right? That's the opposite, that's my hypotenuse. I'm only labeling those because those are the actual numbers that were given to me. We found 20.6, and we actually rounded up to 20.6. So I would try and avoid using the ones you've already rounded to do this, okay? So using the two that were given to me, I would pick the trig ratio that was adjacent and hypotenuse together. So that would be cosine. So I do cosine of B, 19 over 28. What's 19 divided by 28? Another long number there. 7, 8, 6? 7, 8. Okay? And then do, if you got a calculator, right, you would do the inverse of that. So, inverse cosine 0.6786. You would get 47.3. Yeah, you would get that. If you were doing this with the chart, you know, I'd probably assume you'd get 47.5. Okay? And then, like, that's really the run of the work, the most of the work that you're doing, because to get the other angle, you just have to do 90 minus whatever number you just found. Okay, so 90 minus 47.3 would get you this one, with hoping it was 42. Okay? And then you'd be done. Like, I've solved it. I know all the side lengths now. I know all the angle measures. That would be the entire problem. Okay? So this one, you know, whenever you see something like this, just kind of understand it's basically the same thing you would have done yesterday. It's just instead of pointing out where the x's and y's might be and it says find the value of x and y, it'll just say solve the right triangle. Okay? So it kind of, it's just worded a little differently, even though you're doing the exact same thing you would have yes. Okay?
Would it be okay if that's a place on
I'd rather you not, unless it's exactly there. Like if you're using the chart, you realize it's a little bit past where the 47 is, just go to 47.5. Go in between. That's your best estimate. Okay. All right, next thing. All right, next thing's this. Okay, again, the problems are going to be still sine, cosine, tangent stuff. You're still going to be finding side lengths, maybe an angle measure. This is just going to be worded a little differently. These are going to be most of your word problem kind of things. Okay. So to start with, before we actually give you a problem, we'll have to identify what angles of elevation and depression are. Okay, as you can read up there, right? If I talk about an angle of elevation, I'm talking about measuring above something called a horizontal. Horizontals for what we're dealing with is usually like maybe the ground or maybe a line of sight, like from your eyes or something like that. So if you think about angle of elevation as like looking up, an angle of depression would be like looking down. Okay, that's usually the easier way to kind of remember these. So just to a little bit of picture. So this one right here. So if I was down here, you can't really see that horizontal line right there. But if I was said, here's my line of sight, right here, this horizontal line, and I look up to there, that's called your angle of elevation. Okay? If I was at this same point, I look down, that would be your angle of depression. All right, and likewise up here, anywhere you can draw a horizontal line, if it's above or below that horizontal line, you can classify it either as elevation or depression. That's why up here, they have a horizontal line. This angle is measured below that horizontal line, so it's called an angle of depression. Okay? The horizontals will be identified some way. Like usually this deals with maybe like a plane flying, okay, which the horizontal would be the path of the plane under extremely perfect situations of flying in a straight line. Horizontals will also be, like I said, the ground. The ground would be another horizontal that is used a lot. And the other one would be like line of sight, from where like your eyes would be on your body. Right. Those are the very common ones that come up. Okay? But before you get to them, you might see a problem like this. And the problem like this, they just had a picture. What they would say is, okay, in the picture there, identify for angles 1, 2, and 3, and 4, whether or not they're an angle of elevation or an angle of depression based on where they're at. Okay, so if I went through each one of them, if I said, look at angle 1, would I identify angle 1 as either an angle of elevation or an angle of depression? Depression, right? So that'd be because it's going down below that. What about angle 2 here? The elevation, about the depression in this one, elevation, okay? All right, now the reason you go through that is because when you do the word problems, guys, the pictures aren't going to be drawn for you every time. Okay, there might be a little bit, but not every time. So you being able to place these in the right spot is kind of key for you doing the problems, because if the angle's in the wrong spot, you're going to pick the wrong trig ratio, you're going to get the wrong answer. Okay? Alright, so there's 2 problems I want to go through, and then there's a couple ones you guys to do on your own. Okay, so this is the first one. I don't see no picture there. Alright? Just like you got hey guys, just like with any word problem, you don't realize, right, the actual thing you're looking for is always that last sentence. So I know, like even before I start drawing it, the thing I'm actually looking for is how tall this turbine thing is from the ground to top of it. So I know that if I were to just to draw that part and say this represents that turbine, I'm basically looking and going, here's the ground, right, here's that turbine thing. I'm not going to draw the whole thing. But I'd be looking for this part. I wonder how tall it is. Okay? Alright, so if I go back through and I start breaking it apart piece by piece. Okay? And actually I'm going to write the X on the outside. And I'm also going to indicate I want that part of the X. Okay? If I start breaking this apart. It's basically talking about someone standing 53 feet from it. Okay, in terms of what we would measure, 53 feet, that'd always be from the bottom of it out to wherever you're standing at. Okay, so if you got your person standing right over here, right there, this measurement right here would be the thing that's the 53 feet. Okay, because that's just how we would measure in real life. If I said I was 10 feet from something, I'm talking about the horizontal distance I am away from. All right, now they say, okay, your angle of elevation. So that means wherever I draw this angle, that means I'm going to be looking up. Okay, and since it's an angle of elevation from your eye level there, that means that my horizontal is going to be right here. All right, and the angle of elevation will be looking up to the top of it. So there's 56.5 degrees. Okay, now they give you one other measurement right there, and it's talking about how far above the ground that eye level is, which has to be taken into account for this problem. Because if I draw where I have this angle, guys, it's kind of hovering above the ground. So the actual triangle that I'm going to be working with is that triangle that's like hovering above the ground. All right? But I know one side of it. I know this side up here is still 53. Okay? Because where my eyes are and where I'm measuring to where I'm standing is the same. So the only thing I can technically find here would be this part from here to here. Okay, but if I find that part, I can still find from top to bottom because I know that part that's hovering above the ground is 5.5 feet. So all I got to do is find this section here and add that 5.5 to it. Okay? What do you want me to label this? I need another variable. E? Okay, and I'm doing that just for setting up purposes. So, here's my angle. So I'll go through the problem like I would a normal one from yesterday. I go, here's my angle. That's my hypotenuse. That's my opposite side. That's the adjacent side. Okay, I don't have a hypotenuse measurement. I'm going to find the opposite side and I'm giving the adjacent. So if I'm dealing with opposite and adjacent, which trig ratio was that? Tangent. So I'll do tangent 6.5 equals opposite over adjacent. Okay? So you just go about it like you would normally, right? You find the value of tangent 56.5, which what's the value of tangent 56.5?
1.5108.
1.5108. And then you would do your cross multiplying, right? All right, and you said when you cross multiply, what was it? 85.4.
I got 80.07.
80 point what? 3.1. You Okay, and then here's what you got to remember with a problem like this, where they're always telling you again, you're measuring above the ground. That T part that we measured only went from here to here. So the actual height that I'm looking for, this little x, would be 5.5 plus 80.1. The one we found, 85.6. Huh? All right, so that's one problem. Okay, I'm going to do one more, and then I want you guys to do a couple in the book. So you try. All right, so this is the next one. We'll read through it real quick. And we'll start trying to draw that. It's actually not gonna land at all. Sorry, guys. Look at that comment. Okay, so with this one here, usually with this problem, the biggest issue is figuring out which side of the triangle you're going to solve for. And also placing the angle in the right spot. All right, so I know what they're looking for is how far away this plane is from a runway. Okay, so and you would assume the runway is on some kind of ground. Okay, so we'll put it like, sure, well, it's above sea level, so it could be on the ground. But we're assuming it's not. Draw that way. And I put that really far away. This is going to be a super all right, so here's the thing. And when I draw the triangle, because obviously I need the triangle to work with. All right? The flight, the way the plane is flying is technically your horizontal here when you're doing the measurement. And when they do a 3-degree descent, guys, that's an angle of depression because it's going down. So I know where that 3 degrees is. It's going to be 3 degrees below the horizontal. So the horizontal in this case is where your airplane's flying. So the 3 degrees is actually going to go, 3 degrees is right there. Okay? Which coincidentally, guys, 3 degrees looking down is the same as 3 degrees looking up at the ground, right? These are actually alternate interior angles. They're congruent. So you can take that 3 and put it into the triangle you're working. Okay? The other things they give you in the problem before I identify which side I'm trying to find is they tell you that this is the current altitude the plane's at. This is where it's going to. That's how you would find out how far above the ground that actual plane is. Okay? So if I'm saying that I'm at a height of 2,714 feet above sea level, and this place where I'm going to land is at 1,007 feet above sea level, what do you think I'm going to have to do those two numbers to find one side? I'm going to subtract them. Okay? And so if I place them in the right spot, I'm saying this is 2,714 feet. This is 1,007 down here. So when I subtract those two, that's going to give me this side right here. Okay? So I've got this side. All right, now the whole key to this is making sure you understand which other side I want to find. I'm either going to be finding the hypotenuse or this side right here that's adjacent. Which one do you think? The way it's worded, which one do you think makes more sense? The hypotenuse or the adjacent side? Adjacent? Hypotenuse actually makes more sense in terms of this problem. Because I'm measuring the distance from the runway directly to the airplane. If I measure from the runway directly to the airplane, and it doesn't mention anything about a horizontal distance, you're talking about this side. If it was worded such that it said, what is the horizontal distance from the runway to the airplane, then I'd be doing the adjacent side. But if they're not mentioning that, guys, they're referencing the hypotenuse. Okay? So once you've got like the drawing down, because that's the key to it, is getting the drawing right, is you would go back into doing the problems like we did yesterday, right? Here's my angle. The opposite side, the hypotenuse. So I'd be doing opposite over hypotenuse, which is which one of the trig ratios? Sine. So I do sine of 3 equals opposite over hypotenuse. What's the sine of 3?
0.0523.
0.523.
0.523.
All right, and then I'm going to cross multiply, so I got x times 0.0523 equals 1707. So now we divide by those two. So what's 1707 divided by 0.05? 32,000.
633.
And this would be feet, right? Okay. The question asks me the nearest tenth of a mile. So if I know this side is 32,638.6 feet, how many feet are in a mile? So my actual answer here would be that divided by 5,280, which is 6.2. So 6.2 miles. That'd be the final answer. Okay, so the feet would be there, divided by the 5,280 of percent of feet over mile. Okay? The two problems I did are generally the more common ones that you'll come across. Maybe not necessarily in the homework, but like for this type of problem on either like EOC or like my kind of test, these would be the more common ones that I would use.